Today let us discuss about queue. Queue is a data structure, important data structure, which follows FIFO technique. I'll explain you how FIFO technique works. So imagine you are in a queue. That means you are in a bank or anywhere in queue, in theater waiting to buy a ticket, like any queue you can imagine. So it is almost similar to the data structure queue. So there will be some service provider, some service they will be providing. You need to get some service. Whoever comes first, he will get the first service. Then he will get out. Means he will go out first. Whoever come first, whoever come first, they should go out first. Whoever come last, they will go out last. So it is so much clear, right? So much easy. First in, first out. Whoever come first, they should go out first. So that is how it works. So now let us see how we can write code further. I'm going to use linked list. So what I do is I will first take a node. Let me call it as head node. Okay, then I will take a rear. These are the pointers of node type. Initially they are null. If you are familiar with my recent videos of linked list and stack, you'll be knowing or else even if you know about linked list, then that is so much easy, right? So head and rear are, this is rear are the pointers of node type. Initially they are null. Okay, what I'm going to do is I need to create a node, right? First I need to create a node. Okay, I will create a node. What I do is, for creating the first node is different from creating all other node. Means here I have head, I have rear, both are null. So I will create the first node, then I will feed some value. Imagine I am feeding 10. At that time what you do is you make rear and head. Sometime instead of head I will be telling you front, so you can adjust further. So then you can actually write anything, like you can write either head or you can write front. So the four important keywords in queues are head, or some people tell it as front, and second one is rear, another one is enqueue. That means you are putting the element. That is what enqueue means, entering the element, feeding the element. Next is dequeue, that is removing the element. Okay, imagine the first node you have created, you made head pointing on it and rear pointing on it. How do you create the second node? That is so much important. You need to follow 3 steps. What is the first step? You take a pointer, imagine I will call it as a T. I create a node using that pointer. That pointer is of node type. Okay, I created a node and I will feed some data. That is my first. Imagine I am feeding 15. That is my first step. What is second step? Second step, point this rear next to this one. Means I am going to connect this. This is rear, right? Point rear next to this node. Okay. Third point, make rear is equal to T. Right? Rear is equal to T. That's it. That is what we need to give. So if we follow these 3 steps, and this is iterative step, that means next time you need to create a node, right? Rear will be at this position. Let me rub this position. It is not at this position. Rear will be at this position. So using pointer T, I created a node. So here the pointer will be erased whenever I create a new node. Okay, then what I make is I will follow second step. Make rear next pointing on this. Imagine I have given 1. So okay, second step is rear next is equal to T. Okay, what is third step? Make rear point on T. That's it. You can add as many elements as you can. And another condition is, whenever you couldn't create a node, imagine this. See, in C++, in order to create a node, I am using new. In C, I will use malloc. In other language, they are going to use some other keywords. And whenever you use that keywords, that will create a memory in heap, right? Heap is a somewhat much more larger area. So in heap, the probability of getting full is low actually. First of all, node, they will occupy less memory, and if you, and also it depends on the data structure that you are using, that means a data type that you are using. Then imagine that you couldn't create any node, that means heap is full, you have reached that position, at that time only queue will become full, right? What if you, instead of linked list, what if you had used array? At that time the queue would be full whenever the array would be full. So array, if that is full, then queue will be full. But in this linked list, in linked list, whenever the heap will be, heap memory will be full, that means at that time you can't create node. At that time you can give the message queue is full, queue is full. Okay, this is one step. So taking this all thing what I explained, I'm going to write code further. So let me create a structure of node type. Then it has two things, it has a data and it has a pointer called next of node type. We have data of int and next pointer, it is a pointer of node type. Then I have already said I am going to take head, I will make it as a null. First of all, it is a pointer of node type, so asterisk symbol I am going to use. Then again a pointer called rare, that should be equal to null, null, and I am removing this extra equals. Then what I am going to do, I will ask the person to enter how many number of element that you need to enqueue, that means feed into queue. He will give me the result. Then I will use while loop just to, it can use for loop also. Then I will take another variable x and I will ask him what is the element that you need to push, that means enqueue. Okay, he will tell give me some element, then enqueue, enqueue, then x. So I need to create a function in order to enqueue. It returns nothing, enqueue, enqueue. Then it should take x or key value, anything like it is a key value that you need to enter, right? Okay, then you need to create a node, as I said, t, that I explained already. T is equal to new node. Okay, then if t becomes null, if t becomes null, right, then heap is full, that means you need to report that the queue is full, else what you do, else check again if front is, sorry, head is null. What happens if head is null? So initially if head is null, that means no node has been created, that means it is the first node that you are going to create. At that time what you need to do is make head and rear point on t, right? Initially you give the data for, there will be I will feed the data, right? I will feed data here itself, data should be key. Okay, then else what you do, else make, you means you are not creating the first node, that is what else statement should describe. So rear next should be t and rear should be t. So that is how we enqueued the elements. So we need to display, right, whether it has enqueued or not. That is what we need to check. For that I'm using display function. However, I need a head, right? I need head. Head is a global variable, so we don't need to send it from main function. Then void in display from, I will take another node of let it be pointing at head, so it will be pointing at head. So how to print it is so much easy. Again, you are pointing here, it is head, right? This is rear. These are the three elements that I have. Imagine like that. Initially I am pointing p to head, then you print this one and do p is equal to p next, means send p next, then again print, again send, again print, and until where you will do this thing. When p becomes null, means p next, this is null. If it is nothing there, means it is null. When p will become null, right, you stop. So that is what I am doing here. Head is equal to p will be equal to head, right? Then while p, if I give p, means that means if p isn't equal to null, that is what the meaning, but still for clarity I can write like this. Then if now what I need to do, I need to print, right? I need to print the data, then I need to do p next, then I will run this. Let me see whether there is some error or not. Okay, I need to add 3 elements. Those are 1 2 3. Okay, we are able to do that one. We are able to display. Let me take some other values, like I will give 5 1 5 2 12 3 and 43. Okay, it is working. So display is working. Now we need to pop, means dequeue. As I said, pop and push are you are using for stack. Enqueue and dequeue you are using for queue. How to do that? See, it is so much simple. Again, you push the head front, that's it. You will lose this value. That is only way that we can do that. See, 10 has arrived earlier, right? It is the first element that to come. So if you push front one step front, right? If you actually I took it as head, right? If you push head one step front, at that time you are going to lose this element. Which element you lost? The element which has came first, that is going to you are going to lose. That means queue is satisfied, right? So but still I will take a node. In this case I will take a node and I will free this data by using free in C or delete in C++. Anything you can do, you need to remove release that memory. That is very good thing, practice we need to do. Even if we do head move head, if we move head front, then that is also okay, but still we'll remove this one, free the memory. And another important thing, I will return the element that has removed. That is also my objective. And another thing, if you note, means imagine queue is empty, means there is no element in queue. At that time you can't do front, that is head is equal to head next, because head will already be in null, right? It will be null. So whenever head is null, that means queue is empty, there is no element. So there will be no idea of removing any element, because there is no element at all. So what I do is I will return the element that I have removed. That means I have dequeued. Okay, I will make next. Okay, then I need to return int, that is which element that I have removed. Then I will take the function, then there I see. What I do is if head is null, that means there is no element added at the first place. So what you do is you need to print the queue is empty, empty, right? At the first place only you need to do key is empty. Okay, else what you do? It is so much simple. Again, actually I already said that I am going to free some memory, right? So for that I will take some value like t. Let me take it as t node, that is a pointer to node type. So I will take x for returning the element that I removed. Then else what you do, you point t to head, right? You point t to head. Then x is equal to head data or t data, you can tell anything. Then what you do, you push head is equal to head next. You have moved head front. Then what you do, return me, or else I will free first. I'll free free free, I will free what? I will free t, right? In C++, what you do? delete, delete t. Okay, after that you return me x. So what if there is no element? If it is empty, then x will be garbage, right? Let me initiate this to -1. So if it returns -1, that means q was empty. That is what I assume. Now if I run, and I will give some value like 1 2 3 4, 1 2 3 4 is printing, but I am not printing any element, right? So why is that? Let us see what had happened. Okay, I have taken a node, then I have initiated this. If it is null, q is empty. That is what I am applying. Okay, else you do head, take the head, then x is equal to head data, or t data. We can take head and pushing to, it is equal to head next. Okay, delete t, and yeah, it should be working, right? Let me take uh, let me see what I have done. Mistake. Dequeue, dequeue, dequeue. Let me give it as a dequeue. Then I have created a node. Then x is equal to this one, head. When it becomes null, when it is null, I will do this one. This is head. Then head data I will collect. Head next. Okay, sorry. The silly mistake what I did is I did not display it, right? Actually, it should return some value for us. Let me give again some value. Let us see. So it is not anything. Is there any put to now? Actually, the problem was so much simple. See, here, what was the problem is, here I did not give t next is equal to null. So doing this mistake was so much important, I think, because t next is not null. It should be equal to null, right? While enqueuing, you have created the node. Okay, you have created the node. After creating, each time what you need to make is t next has to be made null, because if you don't make null, how like, imagine like I have added 10 15 1. After 1 we don't have null, right? We don't have null. Now I have added null, because I t next has not made null. Now that is what the mistake was. So the mistake is not in dequeue. Actually, the mistake is in display function itself, because how till when this display will work? Display will work when p reaches null. P reaches null. That means the whenever you find null while traversing the node, if you find null like 10 15 1, after that you have null, so you should stop working. So the problem was, so that is why the mistake, that is why we were getting some, we were not getting the result. So now see, I will run now. I will run, but you can observe this 1 2 3 I have given. While displaying, it should simply display and get off the uh, get off, right? But it is not happening. It will take some time, because it did not find that null. That was the problem for it. So now what I am going to make is, I will make t next whenever you create a node, you make it as make the next as null. So at last you should always have null. While displaying, p was not having p was not becoming null. That was our problem. Whenever it reached the last, it was not becoming the null. So if I run now, like 3 elements, 1 2 3, so directly it is giving, it is not waiting anything here. That was our mistake. So displayed, and this is the data that it is displaying, that is this is the data I have removed, that is what it is giving me. So again, if I display, then we should get 2 3, right? We should get 2 3. Again I will run this one. So if I give 1 2 3, then it should give 2 3. That means it has removed, successfully removed 1. So this is how queue work. And most important is, whenever you create node, make its next as null. There is no problem if you don't make it as null. There is no problem, but actually in this display function we needed p to be null, so that was the problem. So when, if you get any doubts, like if you get what to do, just what you do is you simply debug the code. But manually, if you debug, then you will get to know what was the mistake. So thank you.